Okay, question set 1.3.3, Physics 11, question 12. A foolish student wanting to measure the acceleration due to gravity walks off of a skyscraper 320 meters high and starts to free fall. 5 seconds later, Superman dives off the roof to save the student. What must Superman's initial velocity be in order to catch the student just before reaching the ground? Assume Superman is also in free fall. Okay, well, since everything's going down, let's make everything go downward positive. Okay, so what do we got? We got the student, so let's look at these two people, the student and Superman. So we know that he has a velocity initial of 0, because he just stepped off. We know that he's going to accelerate at the pull of gravity, which is 9.81 meters per second squared. The distance in which he can free fall is 320 meters. And we need to figure out his time. We don't know his time anyway. But we should find out his time, because that limits how much time Superman has to get down there, right? Otherwise we don't know what to limit Superman with. So can we find the equation as VI, T, A, and D in it? And the answer is yes. It's this one here. Displacement is VIT plus 1/2 AT squared, in which we have 320 meters equals this whole VIT, it goes to 0 because you're multiplying by 0, plus 1/2 9.81 times T squared. Alright, so we got 320 meters equals we multiply through half of 9.8 is 4.9 T squared. Divide both sides by 4.9. And we get T squared over here. My calculator here. 320 divided by 4.9 is 65.31. Seconds squared. And we take the square root of both sides to get down to just T. So I want to take the square root of that number. 6531 is 8.08 seconds. And I think we want two sig figs here. Yes, no? Yep, 5.0 seconds. So it becomes 8.1 seconds equals T. Okay. Now, Super Duper Man. Okay, looking at Superman now. Superman. He's free fall, so his acceleration is also 9.81 meters per second squared. His displacement has to be 320 or less. And the time, so the time of Superman has to equal the time of the person we had there minus 5. And we know that which equals 8.1 minus 5. Time for Superman then is 3.1 seconds. Okay, let's just create some space to the right to do the calculation. Again, we have all the same stuff we had in the other question, so let's do that same formula, VI t plus 1f by AT squared. Okay, 320. So let's cover this. Now this time we want to know VI, so that you can cover this distance fast enough. T is 3.1 plus 1/2. Looks like I don't have enough space there. Let's move this over. Superman a little more. 1/2. Let's get all this moved over. There we go. 1/2 A, which is 9.81 times 3.1 squared. 320 equals VI times 3.1 plus 4.9 times 3.1 squared, which is 9.61 times 4.9. 47.1. Alright, subtract 47.1 from both sides. And we get 320 minus 47.1, 272.9 equals 3.1 VI. Divide both sides by 3.1. So 88 meters per second equals VI. That must be the initial velocity Superman needs to jump off with. 88 meters per second. And if he's going to catch that guy, he's already 5 seconds behind. Question is complete.